Let's go over a second example of section 3.5, topic 3, solving log equations using log properties. So solve the equation, write the solution set with exact value answers. We have log base 5 of x plus 2 plus log base 5 of x plus 6. Okay, notice that both of these logs have base 5, right? When they have the same log base and connected by a plus sign, we can combine them into a single log using the sum property of log. Okay, so I'm going to write log base 5 of x plus 2 times x plus 6. So when you are combining two separate logs that are adding, we write it as a single log expression, but multiply their log argument. You don't add the argument, you have to multiply the log arguments, okay? So on the right side, we still have 1. All right, so now let's write this in exponential form. The base of the exponential form will be 5. So I'm going to write 5 to the, now the exponent should be 1. So 5 to the first power equals that log argument of x plus 2 times x plus 6. Let's simplify this so that we can solve for x values. 5 to the first power is 5. And on the right side, let us FOIL. So when you FOIL, you're doing x times x. That gives us x squared. Next, we do x times 6. That's plus 6x. To the inner, 2 times x is plus 2x. And lastly, we must do 2 times 6. And that is plus 12. Okay? All right. I am going to combine the like terms in the middle. So we have 5 equals x squared plus, when you combine 6x and 2x, you're going to get 8x plus 12. All right. All right. To solve a quadratic equation, we need to have 0 on the left side here. 0 on one of the sides. So since the left side just has a positive 5, I'm going to subtract 5 from both sides. So that 5 minus 5 will give me 0 on the left-hand side. And on the right side, I'm going to have x squared plus 8x. And when you combine these constants, 12 minus 5, you're going to get 7 plus 7. Now let us factor this trinomial into x plus 1 and x plus 7. Because 1 times 7 is 7, and 1 plus 7 will give us that 8x in the middle. Now let's solve for zeros here. The first parenthesis, first factor will give us x equals negative 1 because opposites make zeros. Now what about from x plus 7? You're going to get x equals negative 7. So I circle these two answers, but we now must check if these are actual solutions to the original log equation because they may be extraneous solutions. So what I'm going to do is go back up and I will copy this equation down to the bottom here and I will check our solutions, okay? Let me start by plugging in negative 1 into the log argument, okay? So if I'm checking to see if x equals negative 1 is a solution, I'm just plugging into the log argument. And when the log argument comes out to be positive, that means this is the solution. So now I'm going to now plug in this negative 1 into the other log argument. So plug in -1 into the second log argument of x plus 6. So that will turn into -1 plus 6, which is positive 5. So yes, -1 passed the check. So we know -1 is the solution to this equation. Now it's time for us to plug in -7, okay? So I'll go ahead and try to plug in -7 now. If I plug in -7 into this first log argument of x plus 2, what will happen? I'm going to get -7 plus 2, which is -5. Log argument cannot be negative or 0. So we don't even have to check for the other. Well, this one will also come out to be negative. So if you plug in that -7 into the second log argument, you get -1. So when you get a solution that makes the log arguments negative, you have to cross it out. That is not the solution to this equation. We call this -7 extraneous solution. Okay? So the only solution to this equation is x equals -1. So remember to please check your answers when you are solving log equations because you may have extraneous solutions.